Your immune system is often likened to an army, always on the lookout for foreign invaders, ready to fight off anything that threatens your health. But what if I told you that your immune system is more than just a simple defense mechanism? It's actually smarter than we often give it credit for, with an intelligence that goes far beyond just recognizing and attacking pathogens. In fact, it can adapt, learn, remember, and even make decisions based on past experiences. Let's dive into the science that proves just how sophisticated and brilliant your immune system really is. Imagine this: a virus enters your body, attempting to hijack your cells and replicate. The first line of defense is the innate immune system, a fast but generalized response. This part of the immune system doesn't discriminate much, it's more like a security guard that's scanning for anything suspicious, ready to tackle whatever comes its way. However, while the innate immune system works quickly, it lacks the specificity needed to target the virus with precision. This is where the adaptive immune system comes in. This is where the real smarts of your immune system lie. The adaptive immune system is not only highly specific, but it also learns from every encounter. When the virus invades, your immune system doesn't just respond blindly, it assesses the situation and decides exactly how to target the pathogen. Specialized immune cells, T cells and B cells, play a major role in this process. When a pathogen enters your body, it is processed by dendritic cells or macrophages, cells that are able to taste the pathogen by capturing pieces of it, called antigens, and displaying these on their surfaces. This information is then presented to T cells in the lymph nodes, the body's immune command center. These T cells have receptors that can recognize specific antigens, like a soldier recognizing the enemy's uniform. Once they recognize the pathogen, they become activated and proliferate, growing into a larger army of immune cells. At the same time, helper T cells release signals to activate B cells, which produce antibodies tailored to target the invader. This process might sound like a basic defense mechanism, but here's where it gets really smart. The immune system doesn't just attack, it learns. After the pathogen is neutralized, memory T cells and memory B cells are formed. These cells remember the specific details of the pathogen, including the antigens they carried. If the same pathogen invades your body again, your immune system can respond faster and more effectively than it did the first time, because it already knows exactly what the pathogen looks like and how to fight it. This immunological memory is the reason why, after you've had a virus like chickenpox or the flu, you typically don't get it again, or at least not in the same severity. The intelligence of your immune system doesn't stop there, it also shows an ability to adapt and fine-tune its response over time. Take affinity maturation, for example. When a B cell starts producing antibodies against a pathogen, these antibodies are not perfect at first. But as the immune response continues, the B cells begin to make small changes to their antibody genes, improving the ability of the antibody to bind tightly to the pathogen. This process is like an immune system, trial and error, allowing it to refine its weapons and become more effective over time. Even more impressively, your immune system decides when to dial up or dial down its response. Sometimes, pathogens are so effective at evading the immune system that it's not enough for the body to simply fight them off. In these cases, your immune system makes calculated decisions, activating specific immune cells and pathways that are more likely to succeed. For instance, helper T cells can direct cytotoxic T cells to destroy infected cells directly, or they can signal B cells to ramp up antibody production. In other cases, your body might recognize a pathogen that's too dangerous to be dealt with by standard immune responses, so it brings in reinforcements from other areas of the immune system like natural killer, NK, cells which can target and kill virus-infected cells that don't display the right markers. What's even more astonishing is the coordination within the immune system. The immune cells aren't working in isolation, they're constantly talking to each other, exchanging information through a complex network of chemical signals. These signals allow the immune cells to communicate about the state of the infection and adapt their strategies accordingly. If the virus is spreading rapidly, the immune system ramps up the production of antibodies. If the infection is localized, the immune system may focus on containing it without causing unnecessary inflammation in other parts of the body. Now, let's look at how immune tolerance plays a role in making the immune system smarter. The immune system must balance attacking invaders while avoiding harm to its own tissues. This is a delicate process called immune tolerance. The immune system has learned to distinguish between self and non-self. Your immune system knows not to attack your own cells, even though it's actively fighting off other foreign invaders. However, this system isn't perfect, and when it goes wrong, it can result in autoimmune diseases where the immune system mistakenly targets your body's own cells. The fact that the immune system can learn to discriminate so precisely between the body's S cells and a virus or bacterium shows just how advanced its ability is. Another fascinating aspect of the immune system's intelligence is its ability to respond to new threats. One of the reasons vaccines work so well is that they take advantage of the immune system's ability to learn. When you're vaccinated, your immune system is introduced to a harmless part of the pathogen, such as a protein or a weakened form of the virus. The immune system learns to recognize this invader and produces antibodies and memory cells tailored to fight it. If the real pathogen ever enters the body, your immune system will already be prepared. What's even more remarkable is the ability of the immune system to respond to brand new pathogens, like the novel SARS-CoV-2 virus that causes COVID-19. Even though the virus had never been seen before, the immune system could rapidly adapt and start producing the appropriate antibodies within days. Finally, the immune system is capable of adaptation in response to repeated exposure to the same pathogen. If a virus like the flu or HIV mutates over time, your immune system doesn't simply give up. Instead, it adapts to recognize the new version of the virus, using a combination of memory cells and newly produced antibodies that can match the updated version of the pathogen. This ability to respond to evolving threats is one of the reasons that the immune system is so successful at keeping us healthy, even as pathogens evolve and adapt. In summary, your immune system is far more sophisticated than simply a line of defense against infection. It's an intelligent, adaptable, and highly coordinated system that learns from every encounter with a pathogen. It can refine its weapons, adapt to new threats, and respond more quickly the next time it's faced with the same invader. It doesn't just act passively, it decides what to do, learns from experience, and adapts to ensure your survival. The more we understand this complex system, the more we can appreciate the incredible intelligence of our immune defense. So, the next time you fight off an infection, remember, your immune system is not just doing its job, it's outsmarting the invader, learning from its experience, and making sure you stay healthy.